Hi guys, welcome to another Learning Electronics Repair video. This is kind of a part 2 video. So I have a HP laptop. Yesterday I published a video whereby I fixed one of the problems, which was that it wouldn't power on. It now powers on reliably, it boots into Windows reliably, but I have the second problem, in as much as it will not detect anything plugged into the HDMI, external TV, external monitor. So this is quite an epic one. It's going to be a bit of a long one, sorry guys, but there's a lot to learn here. I enjoyed it, hope you enjoy it too. So let's begin. So I have it in Windows now, so I can get into Windows, but when I attach the HDMI, I'll just show you where the monitor is. So we just unplug the HDMI, plug it back in again. I get a blue light on the monitor, but it says HDMI no signal and goes off. So the main problem is now that I don't have, and this was the original fault before it kind of went dead. Because I noticed the USBs are a bit dodgy, I'm going to put some switch cleaner in these and see if that makes it work. If not, I'll put my own hard drive on it and see if there's a software problem, see if I can get into the second monitor using my hard drive. Just before I do, I just wanted to show you the HDMI connector. So it's not broken, there's no broken connector in there, but like everything around it, we get this corrosion. I'm wondering if it's that. Otherwise, I'm going to have to have a look at the way it's soldered to the board, I guess. But first of all, let's see if we can actually give it a good clean, yeah, with this stuff. And then I'll wash it with isopropyl as well. And then let's see if it actually works. While it's kind of wet with that stuff, I'm going to just do the usual thing, which is to repeatedly insert the HDMI. Laptop's powered off at the moment, it's not connected to the power supply. So we can just do this. Okay, and then we can just try a little bit of ISO in there with the paintbrush, and then let's see if it actually works. I'll just balance the keyboard, there we go. So let's give it a bit of a clean up with this stuff as well. And while I'm at it, I'm going to do the USBs, because the USBs are not too clever either on this, to be honest. So let's get my nice stiff paintbrush down inside here. Right, let that dry out and then let's see if it works. Okay, that looks fairly dry now. It doesn't take very long to evaporate the isopropyl. Just balance it so I'll also have to get the focus back, obviously. Now I've laid it down. There you go. So I just have the keyboard balancing at the moment with a little bit of a cleaning cloth just to stop it shorting against anything. Let's see. Once again, I'll just insert it a couple of times. Put the power on and let's see if it actually works now. So again, the laptop's booting up, you can see that there. The laptop's starting up, booting Windows, yeah. It has Windows 7 on this machine, I've noticed. Let's see this time if the external monitor works. I'm possibly expecting it won't do until Windows itself is loaded. I did check while I was on site for any software issues and I couldn't spot anything. So let's see what happens now. Okay, we have much the same thing. So we're in Windows on the laptop screen. I'll just put the camera, I'll do. And then we say you can just unplug and reconnect the HDMI. HDMI, no signal. Let's try, out of interest, let's try attaching the VGA monitor. Does it pick this up as a second screen? Because if it does, that pretty much tells me the software is okay. So I need to put the screen onto HDMI. I think it might have done on VGA. So I put the screen on VGA. Yeah, and it works on VGA. So I'm fairly confident that means there's a problem with the connection on the HDMI connector. We'll have to get the board out, get it under the microscope and see if we can see what the problem is. I can just disconnect the VGA. We can go once again with the HDMI to be sure. Again, I'll have to just press the input button on the monitor in case it doesn't switch automatically. And no, it didn't. It didn't detect it. Nothing. Off. On. Yeah, nothing. So that's looking to me, unless I'm missing some important point here, that it is a problem with the HDMI connection. I mean, otherwise, look, you can see the screen goes like you didn't see. The screen blanks out for an instance on the laptop when I connect the VGA cable. So this is what it's not doing with the HDMI. If I disconnect this, yeah, you see it black, come back, yeah. Reconnect the VGA, black, come back. Put the monitor onto VGA, and we will have a picture. VGA. Yeah. Picture. And then if we go the other way, so we disconnect this, obviously the monitor's just gone off, this will go black. Yeah. Come back again. And then we can try the same with the HDMI. Nothing, yeah? Nothing. Doesn't see it. And while I'm at it, I actually have another HDMI on my little portable TV, so we can just also try that one. If I can get it to reach, which I don't think I actually can, not easily. Let's just try lifting this up a little bit. This is not a very long lead from my TV. Okay, we're in. Let's see what happens when we connect that lead. No, nothing. You can see the screen still on the laptop. It didn't blink. Okay, so it looks like we've got a problem with the HDMI connector on the laptop. I have the motherboard out of the laptop again. This is the HDMI connector. It's a little bit hard to see down inside it because of the angle of the microscope. Probably if I got it so I could get it over the end of the desk might be a good idea. Well, if you look with it upside down, I think you can probably see that there is some corrosion inside here still. So there is some dirt on the contacts, and it could be that's the problem. It's a through-hole one, it's not surface mount. I could just put flux on here, I probably will, and just go over the contacts again, but I have to say they look, just see if I can lift this up. Yeah, here we go. Yeah, they look pretty good to me. I don't see any real problem there. I think it's more likely the corrosion inside that is causing the problem. Yeah, they look sort of okay. If we go to the other side again, so if I tip this up a bit, can you see under there all that mess? It might be an idea to actually remove the HDMI and then, if I don't have a replacement one, to refit it. But I do have another possibility with this. They use this laptop basically connected to TV in the hotel bar just for karaoke. So that's the only time they have it connected to the TV. And I can get quite inexpensive a VGA to HDMI adapter, which means we could connect from here and they can plug their TV into it. I have a friend who has one who's a subscriber. He's going to pop down. We can try it. Now, if I sell them the adapter, it's about €40, and we have to kind of offset that against the cost of repairing this, and it's kind of like 6 of one and half a dozen of the other, if you know what I mean. So I will try and clean this underneath. If I have a replacement, I will replace it. Otherwise, let's see if cleaning all this mess off, if I can without taking it off first, will actually solve the problem. But we do have another solution. Not a repair, guys, but comments below. Yeah, I think sometimes you have to think out of the box a little bit. Yeah. I've used isopropyl alcohol and cleaned as best I can under here. It looks much better now. I'm not saying it's perfectly clean. I came in from this side basically, and then switch it over. Effectively, you can see the inner connections are here. So I came in from this angle as well, under here with a stiff brush, and from the back, but this is a very stiff brush, but like a toothbrush in consistency. So I've got that as clean as I can. Let's have to see if it now works. Okay, so this is the moment of truth really. I'm going to connect this up now and see if it works. Okay. Well, this screen didn't black out for an instant, so that's a bad sign. The monitor's come on, but it's just showing a blue screen, no signal. So if pushing down on this actually has any effect on it, let's just put a bit of pressure on it. I'm pretty sure that's soldered well now. So much so and fairly clean, I'd be very surprised if dirty contacts are actually causing this problem. No, it's definitely not working. I've cleaned up the circuit board around here. I've actually also added fresh leaded solder to each of the pins here and then heated it with hot air. In fact, you see I've actually slightly melted the plastic there actually. The connection on this is a little bit strange because it's like it's through hole, but there's nothing coming through here. They effectively flush with the board. There's no pins coming through, which is a bit strange. If we look on the other side, you can see it's now very clean under there. I'll just try and angle it the other way. You can probably see under a little bit better. Yeah, you can see under there now. So I've managed to get that nice and clean. It's a bit difficult to focus on it, unfortunately. Yeah, that's a bit better. So that's sorted out, and yet it still doesn't work. It just will not detect. So I think what we'll do now is test the connector itself. I'm wondering whether this is kind of like broken somehow and pushed in a little bit, although it doesn't seem to be recessed any more particularly than a normal HDMI connector would be. But to test it, we can take a HDMI cable and we can plug this into the connector. So we have a HDMI, and on the other end of the cable I've just attached a HDMI socket. You can see. So what we can do is now we can use the continuity meter and measure basically between the pins on here and the pins here, which are actually on the other side of the board. So we'll turn that over and we'll find it. Yeah. So if we measure now, I should be able to get it just about in shot like so. Yeah. So if I measure from these pins to these pins, we should have effectively each pin with a continuity. I don't have the meter where you can see it, but you can hear the bleep. I'll just get my leads. Everything's a little bit messed up. That is in there. I mean, that's as far as it goes, which also makes me think it may not be inserting properly. I mean, actually, you can see this is the edge of the HDMI, and it only goes as far as there. We won't go any further in than that is for sure. Let's look at the one on the other end. That's of interest. Well, this is, you can see, it actually goes basically all the way in. But is it any further than this one? Let's have a look at the two together. No, it probably isn't. It probably isn't. This is probably inserting as far as you can. Yeah, you see it goes under there anyway. So that's inserted. Let's see if we actually do have a connection, as I mentioned. So I've put continuity mode on the meter. You can hear it, yeah? Let's see what we've got. So we'll start from this end. I think this is actually ground. Yeah, so if we go to this end, it's connecting to the ground. it goes to one of the pins. And I think every third or fourth one here is ground. Well, certainly those two are ground. So if I need more grounds, yeah, that one's ground. That one's ground. That one's ground. Yeah, so these are a signal pair. These are a signal pair. These are a signal pair. So you get ground and a pair of signals, yeah? Ground, pair of signals. Ground, pair of signals. And then I'm not sure where there isn't a ground there. So that's a pair of signals. That's a pair of signals. This is a pair. And this is a pair. It's 4 pairs of signals, differential pairs, and you have a few more wires. So let's have a look. So we'll go from this one, okay? Do we have a connection to the other connector? I'm sorry if it's going to be a bit blurred. It's very hard to hold like this. So I'm just touching all the pins. It appears I don't have a connection, yeah? Go to this one. Just to focus a little bit for myself. There we go. So again, we don't appear to have any connection to there. This is ground. Let's try the next one. Oh, that has a connection to there. Does the one next to it have this one? No, it doesn't. Yeah, so from this one, we have a connection, but the other one of the pair is not connected again. And we can go on here. So this was ground, I think. We'll find it. This was ground. So these two are a data pair. So again, we'll go with this one. That's connected. So that data pair are both connected. Ground. Try this one. Again, it's not connected. And that should be the other part of the data pair. Yeah. So we can say for certain we're not getting a connection through here. I know the cable's good. So I haven't tested that other connector, but I'm pretty sure it's good. Is this not quite going all the way in? No, I can't get any further than that. That appears to be how far it goes. We can have a quick look at that actually. I think if we scratch a little, yeah, scratch a little line there. Okay. It's not going all the way down. It goes to about there. How far is it going through the connector? I'm just interested to see if it's going all the way in. I know it's a slightly different connector. Yeah. Of course, it goes upside down, which doesn't matter. Yeah, it goes in the same distance. I'm fairly sure that's in. I think there's a problem with this connector. I think the only thing I'm going to have to do here, really, all I can do is desolder the socket. I think the easiest way to do this is going to be to put it on a metal stand overhanging. So there's a bit of weight to that. I should be able to get hold of the connector with my long nose pliers and pull it out downwards. I'll just heat it up with the hot air and hopefully this will actually come off. I'll add a bit of flux. I've already put a bit of flux on this previously while I was just effectively trying to remake the connections. We'll get a bit of flux on here as well. To help it, I'm going to put some leaded solder onto these connections, okay, which are where the metal chassis of it attaches basically. I've already added a bit of leaded solder to these, but we can just go over again. Doesn't matter if they bridge now because it's coming off. Okay, I've got some leaded solder on there, so let's get the hot air and we will see whether this will unsolder. So here we go. hopefully not take too long. That leaded solder is now melty because it's so shiny. Let's see if we get it off. Yeah, very easily. Okay, so that's off. While it's still hot, let's clean this up with a bit of solder braid. I have a little bit here. I need to get a fresh roll out. Let's see if we can just clean this up. Probably to clean the holes we'll have to use the vacuum tool, but let's have a look. You might come clean with it being hot. Yeah, it's looking pretty good. You know, I think I might have actually cleaned them, and that's unusual. Yeah. Yeah. Two more. And the braid's getting hot because it's a short bit of braid. Okay. Let's have a look now at our connector and see. Oops. Hot bit of braid on the desk. Let's have a look at our connector now under the microscope and see if there's anything wrong with it. Well, here's the board first. It came off quite cleanly. I mean, there's a few holes with solder still in, but that should come off without too much of a problem. So I may just use the vacuum tool. Let's have a look on the other side. Yeah, it looks pretty good to me. Hasn't dislodged anything, so that came off quite nicely. Let's look at this connector now. Let's look at the connector. So now we can see down inside it. It basically sort of looks okay, but for some reason it isn't okay. There's definitely something stopping this from working. We can see we don't have a connection properly on all of the pins. A bit of solder gone down there. Not sure how that got in there, but it has. Is this little bit here loose or something? No. Thought it might be, it isn't. Let's get a torch and shine it down here. Let's see if we can see any problem with corrosion. Yeah, I mean, it's not very good, is it really? It's a bit dirty. I think this is probably where the problem is, you know. Just a lot of corrosion in here. Let me see if I have another one suitable to fit to the board. If not, we need to see if we can figure out how to clean this one up. But it does look actually really rather badly tarnished inside here. I hope it's coming out well on the microscope. Just doesn't look brilliant. Let's get a new one for comparison. And you can see it's much shinier down there. Yeah, we just get some light in on it, and I'm sure you can see it's much shinier down inside there. Yeah, there, yeah. Compared with ours. Which is very dull. So I think we know what's wrong with it. Whether or not we can clean it is another matter. I've had a look in my stash of bits, and I have various HDMI connectors, but I don't have one with this type of pinout. I could always order some, and they will be here eventually. Tranquillo mañana, as they say here. But they'd rather like this back, so I'm going to see if I can actually fix it. When we were kids, we used to take coins, especially dirty, grubby coins. I'm not sure if I find a grubbier more than that. Let's have a look. No, probably I can't. That's quite a clean one. So, it's a shame. I was looking for a rather dirtier coin. But anyway, we have a coin. So what we used to do with these is we used to use this stuff. So this is HP sauce. It's an English thing. Usually put this on things like bacon sandwiches, sausage sandwiches and that sort of thing, and with breakfast, share English type breakfast. Seems to have lots of labels on it. It doesn't really say what's in here, not in English anyway. I don't find any English ingredients, but I'm guessing you've got something like this where you live. You might even have this if you look around for it. And this is quite acidy. I think somehow near spicy sauce or moro. I think somewhere even will say in Spanish salsa picante, which is spicy sauce in Spanish. So that's what we have. Oh, and Italian, in actual fact, that was. Anyway, spicy sauce. So let's have a play with this. We'll put a bit of this into like a little plastic tub. We'll put our coin in. And then let's give it 10 minutes. And let's see how it comes out. So we can compare it with this one. I mean, they're both fairly similar. Yeah, in colour we can have a look. And we can see how it comes out. And the idea of this being, if this cleans our coin in 10 minutes, we'll then put some inside the HDMI connector. Okay, so a nice blob of HP source in there. That should do the job quite nicely. And we'll put this coin in it. Okay, so there goes our coin. Find something to just stir it in with. It's obviously, look, it's sinking well on its own, yeah. Okay. It's now 15:46. Let's wait till 15:56. Okay, guys, I left it a little bit longer than I intended. Just got carried away answering a few messages, but let's see what's happened to our coin. Well, I have to say the results were less than impressive. I mean, this didn't work anything like it did when I was a kid, I can say that much. It is a bit shinier, but it's not come out overly clean like I thought it would be gleaming. Yeah, I'm sure when we were little that stuff used to work. Maybe the HP source ain't what it used to be, but it didn't do any harm to it. So let's put our HDMI connector in. I'll put a bit of fresh source actually, although I'm sure this would work just as well. Let's put our connector in it. And maybe we'll give it a little bit longer as well, yeah. And I'll save the rest for putting on my breakfast. Oh, fish and chips and batter, by the way. Battered fish and chips it goes nice with. Get all the gloopy stuff into the connector. That's the main thing. I want to make sure it goes inside it. I mean, really, this is acidic like vinegar. The main difference, because of the consistency of it, I'm hoping that it sticks to it better. Okay, so there is our connector. Let's give it a little while. I'll probably leave it a bit longer than I did the other one, and let's see how it comes out. Okay, so I've cleaned it, but I must admit it doesn't seem to have done very much. It still seems very grubby inside here. It doesn't seem like a very clean thing at all. So maybe I need to find something more acidic, possibly, to clean it. I don't have anything to hand particularly. But what we can do again is just actually see if this is the problem. I put 2 of these connectors on, and we have a connection between all 19 pins. Let's try ours again. So let's see. And I'll try to do it on camera. Okay, it's sitting fairly flat, and you can hopefully see them. Right, let's see if we have a connection on all of them. Well, straight away that one doesn't have a oh, tell a lie. It does have, it just didn't have a good connection against it. Okay, let's continue. Fiddly. This is a better one to compare with. Okay, looks like we've got connections on all of the pins. Let's solder it back onto the board and let's see what it does. I have the board there. I mean, it's still a bit of corrosion on it, but it looks relatively clean at least. The connector actually comes in from the other side here, and that does look pretty clean to me. So this is our connector, yeah, and we're going to have to solder this back on this way, so the little legs obviously go into here. What surprises me is that the pins don't actually appear to go all the way through the hole, so that's effectively pushed on. Let's have a look on the other side. Yeah, so you can see the pins don't really come all the way through, which surprises me. I would have thought they would have actually come through the holes, but they don't. So we're going to have to just solder this really and see if it works. I've had some flux. It's not easy to hit the entire area under the microscope. Let's see if we can get these to solder first so it actually fits as flush as we can into the board. Then we'll check how flush it is, and then we'll try and solder these other pins. But I really don't like the way this actually attaches on here at all, to be honest. Doesn't seem very good. We can use some of the thicker solder, at least for the tabs. So see if we can get these things to go. Well, the solder certainly flowed in, it kind of whipped into the hole. I think you can see that. Let's get 2 of them down. I'm pushing a fair bit on that. Now let's have a look to see if it's sitting properly on the board before we do the other ones. I can't easily show you guys, I'm sorry, I can't get the microscope at the right angle. But the connector is certainly sitting properly against the board. Okay, we have that one. I'm still very surprised at the way this actually fits. Okay, and now we come in with some flux, I guess, a little bit of flux is going to help. And we come in with some of the 0.2mm solder, and I want to see whether I can get these to solder down. And then I'm going to check again if I actually have a connection. Let's see what we have. We'll start at the other end, which is the most awkward place to get to here because of this, and we'll work back along here. So you can see the solder's wicking in down the holes. Okay. You can see how well you can work with a big chunky tip like this, by the way, guys. You probably see me do all sorts of micro soldering with this BC3 tip, and it's because it's very chunky, but I'm using the kind of sharp edge of it, if you see what I mean. But it has such a high thermal mass, I can solder very well with it, much better than I could with a fine tip. Okay. And yeah, I'm not getting any solder bridges. Look, I'm actually soldering each pin quite successfully, I hope. Okay. Well, I think that's all of them. Okay. I'll just go over each one again just to melt the solder. I did this before removing the connector, it didn't help. Okay, and a little touch more on top of them. I'm fairly happy with that. Let's get a little bit of isopropyl, just clean it up a little bit so we can see what we have. But it looks pretty good to me, to be honest. I can't get it any better than that. Okay. And I could just try it now. I could just try it But I'd be interested to see on the test meter what I can see here. Do I have all 19 connections? So I'll get my HDMI cable once again and we'll try. I really have too much zoom on the microscope, even on minimum, to do this where you guys can see it. It's easier for me, but let's try it this way with the overhead camera so maybe you can see what I'm doing. So I'm going to go across all the pins on here and see if they connect. Well, that one connected. That one. Yeah. I'm not too worried about where they're connecting, just as long as they do connect, okay? I'll probably have to use the magnifier myself, but I don't know if you'll see it. No, you won't see it. Okay, I'll keep on struggling. In fact, no, I'll tell you what, I'm going to do this off camera. Sorry, guys. Okay, you're going to have to take my word for it, but I do actually have all the connections now. So, I'm sorry, sometimes this is difficult enough to do anyway without trying to do it on camera. But I'm sure you can trust me. So, we have all the connections, so hopefully this will work now. Let's put the laptop back together a little bit and see what it does. It's partially assembled and back together. I have the Windows desktop running. I'm booted into Windows 7 again. Let's see now whether or not this will actually detect my monitor. I'll just make sure the monitor is on HDMI. Yes, it is. Top corner, you can see it. Fingers crossed, yeah. Let's see what it does. Something went click. Blue light came on. And it's still not working. This is proving to be really troublesome. So there's got to be some problem with the signal between the HDMI connector and the processor where the graphics are, I guess. Let's see if we can figure out why it still doesn't work. So what we need to do is understand how the motherboard, the laptop, detects the monitor. And it's actually quite a simple process, and I'll show you and I'll also explain why I've got a resistor stuck in here. This is the pin out for the HDMI connector. It has 19 pins, which are listed here, and we'll go through all this in detail a little bit later in this video, but just for now we're interested in 3 connections. This is a pin out for the connector showing the order of the pins 1 to 19. This is the actually pin out for the socket that you find on the TV or laptop. The plug, which you plug in, is effectively a mirror image of this in the order of the pin numbers. The pins we're interested in right now is pin 19, which is hot plug detect, and these pins 15 and 16, serial clock and serial data. So hot plug detect, basically, when you connect a monitor TV or similar device, it puts a voltage on this pin. It's normally about 5 volts, but it could be anything more than 2 volts. So any voltage greater than 2 volts appearing on here will tell the source device, in this case the laptop, that a cable is plugged in and attached to a device. These serial clock and serial data, these are used to read the data from the monitor, which comes from an EEPROM, and this is what tells the laptop the resolution and other parameters that make a model for the screen. So what we're interested in at the moment is, do we get a voltage on hot plug detect, and can we see any data on pins 15 and 16? I have a resistor, as I mentioned, just stuck into here, which is either pin 3 or pin 17. So if I measure on continuity, and I'm using the Fluke because I need some new batteries for the Kaiweets, by the way, you can see that that is ground. So we know that is pin 17. So with this lead plugged into here, we can figure out where 17 is, and it's actually one of these pins here. I tell a lie, it's this pin. Second one is. So that is 17. So we now know we have 19, we have 16 and 15, and that's the ones we're interested in. I'll just zoom down, you can see it a little bit better. There you go. You can see the pins now. So it's this end is 17. Yeah, you can hear the meter. So this one at the end is 19. This should go to 2 volts or more. 18, 17, 16 and 15, which are these two, should be the clock and the data. Now, the board goes in the laptop upside down. So what I'm going to do is tag a couple of wires on this. I can put it together enough. I need to put the hard drive on to get into Windows, I imagine, so the graphics driver is loaded for this to work. I used to have a breakout cable. In fact, I have it somewhere. So I cut a HDMI cable in half at one point, used a bit of Vero board with a pin header, and effectively made a breakout, so we were numbered 1 to 19, and I could use it to monitor all the connections. But unfortunately, I don't actually know where it is right now, which is typical. Yeah. So this method will work just as well enough. So I'm going to tag some wires on here, as I've just described, put it back together enough to test it, and then we can have a look to see on our oscilloscope what's happening with these pins. You can see I've tagged one of the wires on. I actually had all 3 wires tagged on. So this is pin 19, which is the hot plug pin. 18, 17, this is ground. 16 and 15. And when I tag the wires on, I've taken 2 of them back off now. I had a short, so I was just effectively checking the other end of the wire that I just soldered on the other end, and I had a short between the two. I soldered them a couple times, and then I realised I've actually got a solder bridge here. I don't know whether this has happened originally, whether this is part of the work I did resoldering the HDMI connector when I actually fixed the problem, and as much as I didn't have all the pins connecting. But that's obviously got there some point or other, so that is not going to help in the slightest, and it just happens to be bridging between the pins that are part of the detecting circuit. So let's clean this mess off. I'm sure at some point reviewing this video I'll figure out if I did that during the repair. Let's just get onto the microscope and let's clean this up, and then we can probably try this again actually to see if it now works. So we just okay, that's cleaned now. Yeah, that's cleaned. I don't know whether, yeah, obviously that does connect all the way through. You see, like some of them appear to have like breaks in them, and some of them appear to be connected. Let's just clean that up again. I'm not totally sure whether that's actually correct either. It's like some of them appear to have breaks. That's a ground pin. 1918, yes, 17, that was the ground. 1918, 17, 16, 15. Are they two pads that actually connecting to each other? You'll hear it. Let's have a look. Just to test the meter. Yeah, it's working. You see what I mean? I'm looking at these things here. So, like for instance, there's this one. That connects across. Yeah, it does. But that one doesn't. That one does. Let's just get a bit of flux on. Sorry, let's just get a bit of isopropyl on this. Yeah, I don't know how well you can see it, but I'm just wondering if that should be connected across there. You can see all the other ones, and they appear to have effectively a link there. So these effectively are really test points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Only 15 of them though. So they don't have them in all of the signals. But this one, so I'm not sure we can see, that's 19. We can measure it. We can measure it. So let's see where they go. So we have 19, we know goes to here. We can see it. 18, 17 is ground. So 16 and 15 we're interested in. That's 16. Oh, and this is 15. They're not in order. So I think we'll assume that shouldn't have a solder bridge on it for now. let's take this wire back off and let's see if it works now. I've cleaned that little bit of mess up. Another thing that's obvious as well, it's almost like there's some kind of PCB damage here. Can you see like this here and here? I don't know whether it's just the solder mask has come off, it could be, or whether there's actually some sort of damage to the PCB here as well. Anyway, all we can really do at the moment is try it. So let's try it without that and let's see if it works. Once again, I have Windows loaded. It's sort of partially together. I can just get where you can see it. So I just need to make sure I use the right cable. One of them is my test lead. So this one goes to my monitor. I wonder if it works now. And the answer is surprisingly no. It doesn't blank out on here. I get a blue light and no signal. So even after that it still isn't working. I rather hoped it would, but there we go. Okay, so we're back to the other plan then of actually looking at these signals to see what is happening with this. Let's attach some wires then. So this is pin 19, which is the hot plug, which goes to here. So we can just attach this wire. I've put a little tag on the end of it. You can see it there. Yeah, it's upside down, of course. So effectively, I've just put H for hot plug. Yeah. So we can attach this wire onto here, which is quite simple to do actually with a microscope. Just so we can just get it in there. It's a little bit wide, but you know, actually this one I'm just going to tag it onto there. Easiest place to go. So that's that one. This is either clock or data. It may actually be easy, you know, to use the pins 19, 18, 17, 16. I think this is actually the easier way to do it than those soldering to those test points, as I think they are. Okay, not the best bit of soldering, but it's on. 16, and then let's find the other bit of wire. Okay, I have it. Pin 15, which is this one. 19, 18, 17, 16, 15. That actually does go down there, but I think we can probably just get it on there. Yeah, it's on. Okay, I can just check with the test meter now. So we're on pin 15. Or was it 16? That's pin 15, and then we found the other bit of wire. When we go to pin 16, I just checked they were not short to each other, which they're not. Yeah, we have it, yeah, and they're not short to each other. That's fine. Okay, let's put it back together so we can monitor the signals. I have the wires attached. It's now back into Windows again. You can just see it there. So without the monitor attached, let's have a look on the hot plug lead, which is this one. See what we have. So we have about 1.6 volts on there. It needs to be above 2 apparently. Let's connect our monitor then and see what we have. Okay, so that's the monitor attached. What do we have now? Yeah, 4.47. So that's obviously taking the hot plug pin high. This might be why the blue light comes on the monitor, although we get no signal. Now what I'm interested to see is what's happening on these two pins, 15 and 16. I didn't make a note of which was the clock and data, but it's probably not that important. I'll get the oscilloscope set up and let's have a look. I have the oscilloscope there. I've got it set on half a volt per division at the moment. I'll just connect the ground to the actual metalwork somewhere, and I'll clip the scope lead on so we can actually get a good reading. Just trying to find a decent ground point. That should just do it. Okay, and then we'll click onto one of these. I'm on 16. So pin 16 actually at the moment has a voltage on it. Let's have a look. Well, that's on 2 volts per division, so it actually has. Let's see where it was. Yeah, about 4 volts on there. So let's go on there. Now let's connect the cable and see if we can see anything happen. Okay, so we just plug in the HDMI. Well, it kind of like didn't do a lot, did it really? It didn't do a lot. Let's go again. And we don't see anything on there. I don't see any clock, any data. I see like a little burst of something. That might be it. I'm not sure what the amplitude would be. Let's look at this one. This is the other pin, has the same on there. Okay, plug it in. Don't really see anything. Let's put it on to AC and increase the scale. Okay, I'm on AC coupling now. I can turn the sensitivity up quite a lot. Let's see if we can see anything that looks like data or a clock. Okay, let's have a look. So I've attached it and nothing happened. Yeah, nothing happened. That's on pin 15. Let's go on to pin 16. Okay, plug it in again, and nothing happened. It's not even trying to communicate by the looks of it, even though we know that the hot pin plug is working. It's like the laptop just doesn't send any request, not that I can see anyway. What I'll try, and this is probably one of the last attempts I'm going to have with this. Originally, a long time ago, I said I'd try putting my hard drive on and booting it up and see if it works, detects motor from my hard drive, is it software? But my hard drive, something to do with UEFI or something, it can't boot from it. So what I'm going to do is I'm going to put an old 2.5-inch hard drive in and see if I can boot from USB and install Windows 10 on that drive, install the drivers, and then see if it works. I've already had a look with SDI to see which graphics driver is loaded. It seems to be the latest one. It didn't offer me a newer one. So let me try that. Let me just try installing Windows 10 on another scratch hard drive and see what it does. I've put a fresh installation of Windows 10 on the laptop and it's still doing the same thing. So if I connect the VGA monitor, it works, it detects it, and we get the two displays. Just one moment, there we go. I have to switch the monitor to VGA. There we are. Give it a second or so. Yeah, and there you have it. Yeah, so that's working. We put the HDMI in, just move these little wires out of the way. These are the ones I tagged on for testing purposes. So we can put the HDMI in, and it doesn't find it. It's exactly the same. It makes no difference. We can go to HDMI on the monitor. There we are, and it'll just blue light comes on. But we know the hot plug is working anyway. So this really does appear to be a hardware problem. But I have to say, I'm struggling to find out where the problem actually is. Maybe if I can find a schematic for this laptop, it might give me some idea where those signals come from, but it's looking a little bit dubious if I can fix it. I'll see if I can find a schematic for it anyway. I found the schematic. It was on badcaps.com, so I've downloaded it. And we can see the area of the circuit now. I think this thing with the funny little transformers in is basically the big chunky looking thing that was near to the HDMI connector that I showed you earlier and said I thought it had transformers in it. This is the HDMI connector, and this is what we're interested in. I'll show you that chunky thing in a minute, this thing. But basically, we have HP detect, which is a signal on pin 19, which we know needs to go high. And then supposedly the laptop sees that go high when the monitor is attached, and then reads the data on these lines, HDMI S data and HDMI S clock. Now, these here just seem to go to these capacitors to ground, but if we actually have a look, so we search for the signal HDMI, underscore S data. Just one of them will do. Okay, S data. And we can see where this signal actually goes to. So I'll just click the next. So you can see it goes to a pull-up. And so does S clock. Now we know the pull-up is working because you have about 4 volts or so. This has 5 volts. And we can see on the oscilloscope they are high. So the pull-up must be working, and they're obviously not shorted to ground. They also go to, let's see, yeah, these things here. Now I think I've tried to find a data sheet for this part, TV WDF 104 AD0, and I've struggled to find one, but it suggests it's diodes, and that's what it looks like in here. I think if you look at this, pin 3 is ground, pin 1 is almost certainly a pull-up voltage or a voltage, and it looks like these effectively are like clamping diodes. There's a Zener in here, so the idea is that the voltage cannot go above or below a certain voltage. That's how I can see that. It doesn't show where these pins connect to, but I'm guessing effectively it's the same signal name as here. So I think the signal comes just straight through clock and data, and HP detect, there's the other one. And these are effectively like just clamping or limiting diodes, just limit the voltage that can come in on the HDMI connector. That's what I think those are. It's my best guess anyway. So that's where they go to. And then if we just keep looking through, you'll see we have some circuits here. So we have HDMI S clock and HDMI S data. And these go to MOSFETs basically. And on the other side, look, the PCH, yeah, PCH DDP8 clock, sorry, DDPB clock, yeah, you can see that. And here's the HP detect as well. And again, PCH DDPB HPD. So I'm fairly sure they just go into the PCH chip, and we can check that. So we can have a look, PCH underscore DDPB underscore that will do. We'll find that one. Okay. So again, we hit the up and down arrow, find the next occurrence. Well, again, they go to pull-ups. They go to the MOSFET where we were just looking. And yes, this is the PCH. So they go directly into the PCH under the BGA chip. So all I think we can do with this, if I just go back to the previous instance, yeah, this, is to find this MOSFET, which looks like it's 2 parts of the same MOSFETs, pin 126, 435. So that'd be like a little SO23-6 pin out, a little 6-pin device, and then this is another part 1 of a 6-pin device. So we find these devices and we have a look at what's happening on pins 1, pin 4, and on pin 1 of this one. We can see, does the PCH get the detect, and does the PCH reply? If it doesn't get the detect, I think we have a problem with this MOSFET. That's where we should be looking. We know this is going up and down. Again, if it's replying but there's nothing coming out here, we should look at these MOSFETs again. But it may well be that the PCH just isn't, and then I think we've kind of come to the end of this, because we know it's not software, it's hardware, and we can't really change the PCH, not economically. So let me see if I can actually find out where this is. QG1A, QG2B, QG2A, I think that will be, yeah. Let me see if I can find them. Well, QG1, A and B is this thing. So that was easy to find. So pin 6 goes to the HDMI connector, and pin 1 goes to the PCH. So we can check here on pin 1 to see whether the signal for the hot detector is getting to the PCH. So that we can check. Now I just need to try and find the other one. And QG2 is on the other side of the board, that one. So again, we can have a look, and we should be able to see the connections which go to the PCH. In fact, we will be able to see. And we can see where there's any system clock or data getting as far as this. So let's have a look. This is going to be the easiest side to get at because I can get at this with the board in without tagging any wires onto the other side. Let's assume we can check here first. So if we see S clock and S data coming from the PCH here, we know that the hot plug is working. If we don't, then we have to check the hot plug signal going to the PCH on the other side. We're ready to go. I need the magnifier to see it, but you can see the oscilloscope at least. So let's have a look at the clock signal. So I'm on pin 3. This is the clock signal going from the PCH, and it's just high, yeah? It's about 1 volt. I'm on 2 divisions, yeah? And that does nothing, yeah? There's nothing there coming from the PCH when I plug this in. I'll just go again. Yeah, there's nothing there. Let's have a look at the data line. So I'm expecting nothing on this as well. So this is pin 1. Okay, well again, that's about half a volt or so. Yeah, let's plug it in again. Here we go. Nothing. Nothing. Okay, so we know that we get no response from the PCH. So the last one we need to test now is whether the hot plug signal is going to the PCH. I'll have to do that with the board the other way up, so I'll just have to figure out how to get at it, but most likely I'll just have to tag a wire onto that MOSFET. I've tagged a wire onto the signal going to the PCH, the one we're interested in from the hot detect. So I'm on there. You can see on the oscilloscope that is just low. So we expect this to go high when we insert the HDMI cable. I'll have to use the other hand 1 moment. I have it on there. Get a connection to it. Yeah. Let's try it. Does this go high? No, it doesn't. So it's like the PCH never gets the hot detect signal. Yeah, that's interesting. I'll just make sure I'm actually getting a good connection on that 1 moment. Okay, I've just changed to another scope probe that has a clip-on connector. It's easier. Let's have a look. Well, yes, it does go high. I must have had a bad connection. Yeah, you can see it. So we've obviously got a signal going to the PCH, but we're just not getting a response to the PCH. And I think that's about as far as we can go with this, to be quite honest. I can't see anything else I can actually determine. I think we've just got a faulty PCH, so it's just not responding to that. I mean, it's clear, absolutely clear. It gets the signal. Yeah, and it's quite a low amplitude one, as you would expect it to be. PCH running on about 1 volt probably. So I think we can see basically what the problem is. In fact, look, it's on high now. It's floated high on its own just by me unplugging that, yeah. It's like the signal's even, if you like, unstable coming from the PCH. Yeah. You can see that I'm clear. Okay guys, so I don't think there's much else I can do with this. Now let's have a look at how the HDMI connector actually works. So we have 19 pins. I've already written 1 to 19, save you watching me do that. So the first 9 pins are basically carrying the picture data, the image. Now HDMI is not like VGA and other systems where you effectively have a red, green and blue signal, RGB. It's digital. So what we actually have is we have the data line 0, 1 and 2, yeah? And each one is what's called a differential signal. So you've got data 2 plus. Here on pin 3 we have data 2 minus. Yeah. Pin 4 we have data 1 plus. 6 is data 1 minus. And then 7 is data 0 plus, and 9 is data 0 minus. The pins in between here, here, and here is the shield. So each one of these connections is effectively like a pair of twisted wires with like a outer braiding, a shield, a ground if you like. So that's what they are. Now each of these data lines uses what's called LVDS, low voltage differential signal, and this is basically the same way that a PCIe lane works, that SATA works, that USB works. They all work in the same way, and the reason being is because it's a very efficient way of sending data down long connections or long cables while maintaining the quality of the data, so that you don't have, for instance, if there's some interference in the signal, you don't lose data. Imagine if you sent data down a wire effectively as a series of pulses, yeah? Okay, so I'll move it because it's on behind me. A sequence of pulses like that. Now, this might be 0 volt and this might be whatever voltage you want, let's say 3 volts, could be anything. And you send the data by effectively a high or a low. The problem with this is when you've got some interference on a line, say you've got some like mains type interference like this being picked up, yeah, your data now effectively looks like this, so it's kind of superimposed on the noise, the waveform, the mains form, yeah. Or if you get like some sort of spike, for instance, you would have a situation where your data is down here, and then all of a sudden it's up here, okay, and then it's back down here again. It's very difficult for the receiving device to understand that. It's what voltage is a 0, what voltage is a 1. So LVDS is designed to get around this. It gets around another problem as well. If you're sending pulses of data like this, the device that's sending the data, it takes a finite time for a MOSFET or whatever to switch from off to on, yeah? And that finite time increases with the height of the pulse. Effectively, the higher the voltage it's switching, the longer it takes to go from off to on, yeah? If you made this waveform much smaller, say 1 volt high, you would exacerbate this problem, because now the height of the interference, if you like, the noise ratio to the signal is worse. Yeah, you got a worse signal to noise ratio. So these are various problems that we get around with LVDS. So much so that everything uses LVDS these days, basically. So the way LVDS works is like this. You have 2 data lines for 1 channel of data, 1 set of pulses, if you like. And you have a circuit whereby into the circuit come your pulses. Okay. And this drives into a special type of amplifier with 2 outputs. And what happens is, basically, when the pulse is low, for example, this output is higher than that one. And when the pulse is high, this one is higher than this one. So you end up with an output that sort of looks like this. This is one of your outputs, yeah? And the other output, and let's draw it in a different colour, is like this. Yeah? So you can see it. What we've got now is for a logic 1, for instance, this one is higher than this one, yeah? This pin, data 2 plus, is more positive than data 2 minus, yeah? And the receiver can detect that one is higher than the other. On a logic 0, this pin, data 2 minus, which is the black line, is now higher than that one, yeah? So on the black line, this is positive and this is negative. You see what I mean? So in one instance, the orange wire, if you like, is the highest, and in the other instance, that one is the highest, yeah? So the polarity of these switches backwards and forwards as you send serial data. Now, imagine you superimpose that onto some noise, yeah? So we've got some noise. Okay? And on this noise, we've effectively got our signal. We'll just draw a bit of it. That should be enough. Yeah, because it's LVDS, the other signal is like this. Yeah. But you can see, I'm sure, that no matter what the voltage level and what the noise is, you still have the same situation. Either 2 plus is higher than 2 minus, or 2 minus is higher than 2 plus in volts. Yeah. And that's how LVDS works. And as I say, it's used PCIe. A PCIe lane is that, for example. It's all LVDS. So on here, we effectively have, if you like, the equivalent of 3 PCIe lanes full of data. Yeah, we got lane 0, we got lane 1, and we got lane 2. So that is how the data is being sent, the image data, yeah, and for that matter, the sound is also included in that as well. That's how it's sending the data from the source, the laptop, games console, satellite receiver, whatever, to the target, the display, monitor, TV. That's how it works, yeah. Now, because these are all these low voltage swapping over signals and the data rate is very, very high, it's very difficult to see this. If you try to look at it on an oscilloscope, well, first of all, where you put the ground, you've got to put it on shield. And even if you have 2 traces, it's very hard to see this because it's switching so rapidly. You just see like a kind of a high frequency noise type thing. That's what you will see if you look with an oscilloscope. But the other signals on here are a bit easier to see. So we have this data coming down the line, yeah? But the target device, the monitor, needs to know at which point do I check to see which of the 2 inputs is higher than the other one, yeah? And it needs to check, obviously, at a set point. It needs to know the speed of the data, when to look. It needs to be synchronized to the sending device. So the next 2 pins are the clock, TMDS clock, yeah, plus TMDS clock minus. And again, in between is the shield. So if you open up a HDMI cable to see what's inside it, you'll find 4 shielded pairs of wire, and that's what they are. 3 of them are the data, and the 4th one is the clock that synchronizes so it knows when to look at the data. That's what's on those pins. But HDMI has 19 pins. Why? Well, we've looked at some of them. Pin 19 is hot plug. So when you connect the HDMI to the target device, the monitor or TV, it puts a voltage on here that's greater than 2 volts. We could see our monitor was putting 4.5 volts on here. And the source, the laptop, detects that voltage and knows something is plugged into it. Okay? 17 is ground. This ground is not these shields, it's a separate ground. And this ground is only relative to the signals here. It's not for those as such, yeah? Maybe connected together in the source device, but it's not the same, basically. So that's your ground. We know 16 and 15 have SCL for the DDC. This is the device data channel, yeah? And they have, actually I've really the wrong way around. This is SDA, serial data, and this is SCL, clock, yeah? For the device data channel. This channel is where the device sends the information, and by device I mean the monitor, the TV, the target, the display. This is where it sends the data to the source to say what it is. Now this data comes from an EEPROM inside the monitor, TV, whatever, yeah? And that EEPROM contains data which is called EDID. This EDID stands for Extended Display Identification Data. It's held in an EEPROM on the device, and normally it's actually certainly on a monitor or a laptop screen, which a laptop screen connects the same way to the motherboard. It still uses this system basically. The EEPROM is usually on the circuit board that's actually bonded to the monitor. So you've got your monitor panel and a little circuit board at the bottom with some like little brown flexible tabs, and on that circuit board is where you will find the EEPROM. Usually, yeah. Could be on a separate board in the TV, but on the monitor it's normally there. Now, this EDID, this data, is what tells your laptop or your other source device the parameters for the TV, for the monitor, what the resolution is, and other information. Okay, that's how it knows what's attached to it. It has another purpose as well. The other purpose is that when you send data from a source device through the HDMI to a target screen, the data is actually encrypted. So HDMI encrypts the data going to the TV, and the TV decrypts it. And this EDID contains the information, the key to unlock the data. Yeah, so effectively, the EDID, if you like, gives an encryption key to the source, and the source uses that encryption key to talk to the destination, the target, and that encrypts the data on the HDMI cable. It's to do with copyright, basically. The idea is you're not supposed to be able to record HDMI. Not to say it can't be got around, but that was the reasoning behind it. Yeah, stop people making digital copies of digital copyrighted information. Okay, we can talk the semantics, how effective it is, but that's why it was done. So if you have a problem with the EEPROM, a corrupted EEPROM on the target device, the monitor, one of a couple of things can happen. One of them is that, for instance, the sending device, the laptop, doesn't know the correct resolution for the monitor, so you might get half a screen stretched across the full width. You might not get enough lines. You might get some problem with the picture size. You might get no picture at all. These sort of problems can be caused by a corrupted EEPROM there, this EDID. So that's what that does. So we're only really left now with a few pins. Pin 18 is a 5 volt positive supply that can supply 50 milliamps. This is used where effectively you want to power another device from the source or from the destination. Good example, if you have like a HDMI splitter coming out of a laptop, the laptop can power the HDMI splitter to split it into 2 or 4, or we can have a separate power. That's what that's for. The last one's HEC data and CEC. CEC, this is consumer electronic control, yeah? Control. This is effectively a method by which you can control a device attached to HDMI. It's not particularly used. I can't think of any good examples, but you could effectively get the sending device to control some features of the screen, yeah, but apparently you can't switch it off. Yeah. The other one, HEC data, this was originally for sending Ethernet via HDMI cable, so the target device can actually access the internet via the HDMI cable. But more these days it's not used for that, it's used for something called ARC. ARC, you'll see this on a lot of HDMI connectors, on TVs and such like, always on target devices, and ARC is audio return channel. What you would normally use this for is so that you can record from the HDMI on the TV and you can effectively get the audio coming from the source. So source in with audio, it displays and puts sound on the TV, and the audio return channel would feed the audio back out to a soundbar, for example. Yeah. So that's everything really you need to know. That's all the pins. The ARC we're probably not interested in. The although CEC we're probably not interested in. So the way it works basically, I've pretty much described. I'll just put it step by step. So first of all, when you plug in your target, your monitor TV, you get a hot plug, which goes up to 5 volts or thereabouts. Certainly more than 2 volts, yeah? Once you get that, you get the source device. Yeah, so this is your monitor. So your monitor says hot plug high. The source device then uses SCL, SDA on pins 15 and 16 to query the target. Yeah. What are you? What are your parameters? Okay. The target uses the same lines to reply. I'm a monitor and I can do this. Yeah. So that all goes on there in 15 and 16. At the same time, also coming from here is the EDID information. Not the EDID information, sorry. The encryption key, yeah? Coming to here. Once you've got that, your source now uses the channels, yeah? Lane 1, lane 2, lane 0 and clock. So L2, L1, L0 and clock. And it uses this to send the encrypted data to the monitor, and the monitor can use the EDID to decrypt it. So that is the sequence of events that happen with HDMI. Before we take another look at our HDMI connector, I'll just mention one other thing. The data lines and the clock, the 4 LVDS lines, actually connect from the PCH, in this case, the sending chip, via little inductor beads. So you can see the kind of like little beads like so. I did show them on the schematic earlier, and I mentioned I would show you where they are. So there's effectively a pair of these on each one of the lanes. So for instance, like on lane 2 you would have 2 plus 2 minus. This is going to the connector, and then coming in 2 plus 2 minus from the PCH, or whatever chip is generating the signal on your device if it's not a laptop. So we have that as well. Now these little inductor beads, sometimes people call them fuses. I'm not totally sure they are fuses, or they certainly are inductors, but these can go open circuit. So if you have one or more of these open circuit, you may well find with a laptop, when you plug it in, if this is working, it will detect it, but you won't get a picture. And you'll know it's detected because the laptop will tell you. On other devices, you may just not get a picture. So we should check these as well to make sure that we have no open circuits. Here are our little inductor beads. I've got the multimeter where you can see it. I'm on continuity range. So basically each one has a pair of coils coming through like this, and we can just check them. Sometimes a bit awkward to get a connection on them. Yep, I had it. So that's good. I need 2 needle probes for this. I've ordered some more. One of mine broke. That's good, you can hear it. We'll just go for this one. In fact, actually it looks like they connect to these capacitors anyway. Yeah, they do, so we can measure through this way. Okay. There's another voltage on these MOSFETs though, and that's from pins 2 and 5, which is 3VS. So this should be a 3 volt supply. If I just get onto it, there, it only looks like about half a volt, but this supply goes all over the place. I'd be very surprised if there was a problem with it, but just check again. Yeah, it's like about 1 division. It's about half a volt basically. Yeah, that's interesting. I wonder if that voltage is wrong and that's why this is not effectively working, but I'd be very surprised if that's the case, because I expect a lot of stuff not to work. Again, we can just go on these. Yeah, about half a volt, that is. I'm going to have a look to see where that actually comes from. I think I might be getting somewhere with this now. This QG2, which is the dual MOSFET on this side. So this is processing, if you like, or interfacing from the hot plug signal coming in, which is a 5 volt signal, into a signal which goes to the PCH. And when hot plug goes high, and we know it does about 4.5 volts, we measured that earlier, the output goes high, which only goes to about half a volt. And I don't think that's enough. I mean, it could be that anything above 0.2 volts is classed as a high signal, logic 1. But I think it's more likely to do with the gate voltage on this as well. And I'll just show you on the schematic what I think now. And then we'll have to prove if I'm right or not. So this is the schematic. And you can see, as I was just pointing out, 3VS is on the gate of both of these, but it's only reading half a volt, and 3VS also goes to this MOSFET as well, and I suspect they're all connected closely together on the PCB. This signal 3VS goes all over the place, so if I just search 3VS and start going to the next occurrence and so on, you can see, yeah, I found it here, 3VS again on another part of the circuit. That's the WLAN, which is probably a derived voltage from the 3VS one or the other. Yeah, 3VS is here again. And so on. So this voltage pretty much goes to a lot of places. And you would think that if that voltage is missing, it's not going to work, yeah, the thing isn't going to work, but it's quite possible that that voltage is there, and if I go through, I'll show you again where it comes from. So from this chip Q21, I think this 3VS will be here. If we can measure, this might actually be a QFN, but I might be able to find this capacitor. I wouldn't be surprised to find that voltage is there, but it's not connecting to our MOSFETs by the HDMI connector. And I also have a theory why that may actually be as well. We do know there's some sort of damage here to the PCB right by the HDMI connector. And I'm just wondering if there's a broken track somewhere around here, which is why 3VS is missing. That would sort of explain why the laptop actually works, because that voltage is present elsewhere, but why the HDMI auto detect doesn't work, because it isn't present here. So let's find Q21 and then let's measure the resistance back to here and see whether or not that actually is connected. I've looked all over this board several times under the microscope trying to find this chip Q21. And I can't find it. I just cannot find it. I don't know if our board is a different revision to the one in the schematic or something like that. I did find some bits of corrosion here and there, which I've cleaned up on the way round. But this shouldn't be difficult to find. Basically, it's a 14-pin chip with a ground pin underneath it. I have the part number APE8990, and I also have the package DFN, which is dual flat no lead 14 pin. So from that I can find the data sheet, which is here, and you can see what it looks like. So it shouldn't be difficult to find that, and yet I cannot find anything that even is in that package on the board. And I've really had a look. I've removed even the CPU heatsink and things in case it's hiding somewhere, and it is just not there. However, from the datasheet I can sort of see how it works. So effectively you have two input voltages, two output voltages, and you can switch them on and off, on one and on two. If you look at the schematic, you see here we have 3VDS, which goes to 3VS, and that is controlled by this pin on 1, on 3, which comes from sleep state 3. So this comes from the Super I/O, and obviously when it's in sleep state you can switch this power rail on or off. The same with this one is on 2 as well. In fact, it's the same signal. So these two voltage rails get switched on or off depending on the control signals here. Because I can't find out where it is, I think what I'm going to try is just to see if it fixes the problem. First of all, I've cleaned off the rest of the corrosion. Let's see if it works. Otherwise, if I can find this voltage 3VDS and see where that comes from, I'm actually going to connect from there to this voltage on our MOSFETs. I'll just make sure the power pins are all connected together from one side to the other. Obviously there's two dual MOSFETs, but I reckon they probably are, certainly for the three switches we have, the hot switch and the data and clock lines. So I'm going to put 3 volts on there and see what it does. Let me try and find out where this plus 3VDS comes from and see if I can pick that up on the board somewhere. And I suspect if it works like this, it'll probably work. Whether it messes up the sleep state, I'll be very surprised actually. I think these voltages are switched on and off just to put it in a slightly lower power mode when it's in sleep state 3. I don't think it would actually stop it going to sleep and waking back up. I also suspect for what they're using this for, if I can just get it to work, they'll be quite happy. Let me see if I can find this plus 3VDS, see where that actually comes from. So plus 3VDS. Okay, I have it there. Now I just need to search. Well, it comes from plus 3VDSP via a jumper. That's where it comes from. So we can find that. That comes from here. So it comes from this buck regulator. We can see the high side and low side MOSFETs here. We can see the controller. So hopefully I can find the MOSFETs PQ301 and PQ302 and the coil PL303, and I can pick the supply up from there. Let me see if I can find this. Okay, so I found it. This is PL303. I'm sure you can see it with the 2 MOSFETs. This goes to the output capacitor here, and in fact P303, this is the jumper where it effectively becomes the 3VDS effectively. So I'm going to power this up, just make sure I have 3.3 or 3 volts on here, and then I'm going to connect that, assuming this doesn't work now I've cleaned the last of the corrosion off. I'm going to connect a wire from there to power the little dual MOSFETs. That's OG1 here on pin 2 and the OG2 on the other side. In fact, I can get the power there on this end of this resistor, so I can take this wire or something similar. So let's have a look first if it's working now after cleaning most of the rest of the board up, and if it's not, let's put this on and see what happens. I've got it connected back up again. We're in Windows 10. We can put the monitor back on, just make sure it's on HDMI. Yeah, it's on HDMI. You can see the top corner there. Let's see if it works now I've cleaned the rest of the corrosion off. I don't think it will, but let's have a quick look. Well, no, this screen didn't blank out. The blue light came on the monitor and it's saying no signal. So it's doing what it was doing before. So we can shut this down. We can check to make sure that we have 3.3 volts or 3 volts on that supply rail, and I'm going to connect it to this little bit of wire I've tagged on here. It's just out of shot, unfortunately. That bit of wire there, that's the 3 volt supply to the MOSFETs, and I've checked on the one underneath, the QG1 and QG2, and all the pins 2 and 5 are connected to each other, so that will power all of them if I connect it to a 3 volt supply. Yeah, you see it there. I'm going to solder onto the end of this capacitor, the positive end, if this has a 3 volt supply, which according to the schematic it should have. This is going to be fairly easy to test. I don't need it powered up with a monitor or anything, just by switching it on. So at the moment it's effectively in standby, and I'm guessing this supply rail is not there. Let's just find a good ground point and let's have a look. So we have nothing there at the moment. Let's power it up. Yeah, it's powered up. Do we have it? Should have it. Yeah, 3.4. So I'm going to go from there onto the end of my bit of wire, and then let's see if it actually works now. I've tagged a bit of this very fine wire on that somebody gave me from a phone repair shop. They're not long enough, so I joined two together. I didn't have any heat shrink narrow enough for this wire, but I've put a bit of insulation tape on. It kind of sits where the other memory DIMM would go, even though it's not fitted, but if it was fitted it wouldn't be in the way. Let's start it up then. So we'll put the power on, we'll start it. It does start. We do get a picture on the screen, just booting at the moment. So let's see if this actually possibly does work. Just to mention, by the way, in the kind of a part one, it wasn't really a part one, it was more of a teaser for this. People mentioned about pressing the key, which is the F4 on here, which is old function F4. That doesn't make it detect the monitor, by the way. I tried that previously, it makes no difference. It still does not detect the monitor. But hopefully, you never know, with our, I'm not sure I could call it a repair, but with our hack it might work. Okay, so it's booted into Windows. Let's take our lead. You can see the monitor over here. Let's see what it does. And in fact, it still doesn't work. The function F4 doesn't do anything. And we can just make sure we have actually got the 3-volt supply on these MOSFETs now. These dual MOSFETs. So the one is way down here. I need to use the magnifier, but I will put the meter where you can see it. So we can just put the test meter here. We want to volts. And let's see if we actually have our 3-volt supply. Okay, this will have to do. Let's see. I'm going to use the black lead, so it will be negative because the red lead is not as good. The black one's a finer tip. Yeah, minus 3.4. So we have a supply on there. I've just tried the VGA again. That's still working, so it's still detecting the VGA. So we haven't caused any problems as far as I can tell. It's just this just does not detect still. I thought that might have fixed it, to be honest, guys, but obviously it hasn't. So I've attached the little wire again onto the hot plug connection going to the PCH. So we can attach our oscilloscope probe. I've set it to 1 volt per centimetre, and I've actually put the reading scale on now, the measurement. So it's actually telling me I have 2 volts on that pin now, rather than like about half a volt, which seems to be about right to me. Now, when I connect the hot plug, it just goes to 2.08 volts, so it doesn't change very much. Yeah, there's really very little difference in that. If we have another quick look at the schematic, we might be able to figure out what's happening with it. This is the schematic. This is the 3VS that was missing, the push 3-volt supply, which I now have. This is the pin going to the PCH, and we can see here is actually a resistor, a pull-up resistor. So it looks like this circuit effectively pulls the voltage up here by standard, which is what it is doing. It now has about 2 volts rather than half a volt. When I connect here, this is the 5 volt level. We have about 4.5 volts on the HDMI cable. And I'm thinking, I'm just trying to figure out the configuration of this MOSFET, but it might actually be that that effectively switches it off and this goes to 0, it inverts. Or it may be it goes higher, but I think it probably inverts it, to be quite honest. I think the idea this is supposed to go low when this goes high, because it's already pulled up already. That sort of makes some sense. So The only thought I have now, and it's got to be worth a try, is to change this MOSFET. And it's the same MOSFET as we have in the, or rather dual MOSFET package that we have on the other pins here, the data and the clock. So I'm pretty sure I can probably get these, and I think that's the next thing to do, is to change the MOSFET to see if that will fix the problem. But unfortunately, I don't have any of these dual MOSFETs, and now I will have to order them. So that's as far as I can go with this video today. So in the end, guys, I couldn't fix it, or at least not today. I will order some of these little dual MOSFETs and see whether that fixes the problem. It is possible it's faulty because that component effectively is exposed to the outside world. It's connected directly to the HDMI cable, and whatever voltages get stuck into the other end of the HDMI cable comes straight in there. So there's a chance. I mean, it's a very tiny component, probably a bit difficult to test, and they're so cheap to buy, I might as well just get some replacements and wait until they arrive. I think we've learned a few things here, and I do actually feel I've achieved the objective of this video. So, although I couldn't fix it, one thing you need to learn, if you haven't learned it already in electronics repair, you can't fix everything, guys. I know there seem to be some YouTube channels that do fix everything, but believe me, that is not reality. That is not the case, yeah? You can't fix everything. But what we have done is had a very, very close look at HDMI in depth. And I'm sure now at the end of this video, I hope you made it this far, you know exactly how HDMI works, you know exactly what to look for, you have a very good understanding of what can go wrong with it. And I'm sure you'll have a much better chance now of repairing HDMI when it isn't just a broken connector than you had before you started. So I hope you enjoyed it anyway, I hope you found it worthwhile anyway. I certainly did, and I certainly learned some stuff this time. And I will see you all soon on another Electronics Repair video. Ciao for now, guys.